Advanced Marketplace welcomes you to this webinar series highlighting the importance of having a configuration management system, CMDB. This series will demonstrate areas to leverage a CMDB and gain valuable insight while supporting numerous IT functions into your organization. During this webinar series, we will feature HP software products to illustrate the value of these concepts, but similar successes can be achieved through the integration of numerous tools available today. There are 4 sections to this series, and the following topics will be covered. Application mapping in a CMDB. Utilizing CMDB for change and release control. How a CMDB supports efficient business service management, runtime service model. Improve application performance and quality with a CMDB. Application lifecycle management. This is the first presentation in a 4-part series covering application mapping in a CMDB.
Hello, I'm Logan Akins, and this is my presentation, Cliff's Notes to Application Mapping in UCMDB. Everything you need, nothing you don't. Before we get started, I want to share a bit of information about Advanced Marketplace. We're based in Tampa, Florida, and we're established in 1996. We specialize in ITSM, IT operations, application lifecycle, security, and training. Please feel free to look us up using any of these social media outlets. Before we can discuss HP Universal CMDB specifically, it's important for everyone to have a very basic understanding of ITIL and CMDB. A Configuration Management Database, or CMDB, is a fundamental component of the ITIL service management process. ITIL, or Information Technology Infrastructure Library, is a framework to service management. A CMDB is a repository of configuration information related to all the components of a computing environment. In a perfect world, this would be made up of all information about every computer in the environment. This information would range from the host name of a server to the version of its BIOS. The most important point that I can make here is that ITIL is not software that you install or other technology that you implement. It is a set of books that outline a set of best practices for running an IT organization. A CMDB is an integral part of this theory. The information stored in a CMDB is organized and represented as configuration items or attributes of configuration items. Configuration items are usually referred to as CIs. The diagram on the right shows CMDB as being the center of incident, problem, and change management. This makes sense because most incidents, problems, and changes relate to computers which happen to be stored in the CMDB as CIs. CMDBs generally have some sort of discovery mechanism. The servers, or CIs rather, detected by the discovery mechanism are referred to as discovered CIs. A logical CI is normally used to represent a group of CIs. A good example might be an online banking application. All of the servers that host web pages or apps, as well as all of the servers that host databases used by our online banking application, could be grouped under one online banking application CI. This online banking application CI would be manually created by our user, and all of the servers that make up the application would be grouped within. HP Universal CMDB is Hewlett-Packard's implementation of a CMDB. UCMDB consists of a web-based user interface that acts as a front end to a database. Management of CIs and how they relate to one another is managed via the UCMDB UI. UCMDB also provides various scheduling and maintenance tasks to keep CI information up to date and relevant. As I stated previously, CMDBs generally have a discovery mechanism, and UCMDB is no different. In UCMDB, this functionality is known as Data Flow Management, or DFM. DFM is the mechanism that populates UCMDB with CIs. DFM queries machines on the network using various protocols executed by data flow probes, or DFPs. The image in the lower right shows data flow probes connecting to the UCMDB server through a firewall and the UCMDB server acting as a front end to the database server. Protocols used for discovery include, but are not limited to, PowerShell, SSH, WMI, WebSphere, SQL Server, and Oracle. Here's a quick run-through of Discovery Control Panel. If you see something during this demo that captures your interest and you have additional questions about it, please contact me using the information shown at the end of this presentation. What we're looking at here are host connection discovery jobs. These are some of the first jobs executed by HP UCMDB as it attempts to query a target host. Host connection by shell attempts to connect to that host via SSH, Telnet, and NTCMD protocols. PowerShell and WMI protocols have their own dedicated job. These jobs are used to discover anything about WebSphere. HP UCMDB can discover information about all of these databases out of the box. Our slide deck specifically mentions SQL Server and Oracle. Here are the jobs that are used to discover information about those types of databases. So what are the advantages to using HP UCMDB? UCMDB is able to leverage the information gathered by other HP tools. Integrating with other tools helps to increase the discovery footprint, as the tools may have access to devices that HP UCMDB does not. Ascent Behringer may have CIs that have been received by a company, but have not been set up on the network. In other words, they're still sitting on the dock waiting to be used. HP DDMI may have CIs that exist in a secured environment that does not allow discovery queries. Yet they have a DDMI agent and are in the DDMI repository. Integrating UCMDB with DDMI ensures that these servers are known by UCMDB. HP NNMI may have CIs that aren't known to UCMDB because there was a network not known to the person who implemented UCMDB. Just as UCMDB is able to leverage the repositories maintained by other HP tools, it is able to leverage the repositories of other non-HP tools. These include Microsoft SCCM SMS, CA CMDB, Atrium, VMware vSphere. UCMDB is also able to import from XML and Excel spreadsheets if they're properly formatted. Here's a look at Integration Studio. The easiest way to get a look at the available integration adapters is to create a new integration point. Here we can see the adapters for Asset Manager, NNMI. We have several versions of Service Manager. A little further down, we can see the integration adapter for Atrium, CA CMDB, and Microsoft SMS. Modeling is the process of defining logical CIs. In UCMDB, a business application CI is a good example of a logical CI that represents a group of discovered CIs, as we discussed earlier. But we have a couple ways of creating models. An instance-based model is a static grouping of our CIs, while a pattern-based model can be set up to group CIs based on the information that they contain. For example, servers that are hosting an online banking database or have an online banking software package installed can be grouped into the online banking business application. The advantage of this is that if a new online banking database server is spun up to help with demand, then it will automatically be added to the group. This is Modeling Studio, and we're looking at an instance-based version of our online banking application. Random servers 1 through 9 have been associated with our online banking app, and we also have a pattern view that displays information about our app. Here we've defined a business application CI whose scope has been limited to online banking instance-based. We'll display nodes associated with the application, as well as CIs related to those nodes. Specifically, we'll be displaying .NET Web Apps, software packages who can be found in Add Remove Programs dialog of a server, and SQL Server databases, all whose names contain the phrase online banking. To see the results of this query, you click the Preview button. Here you can see our online banking application and all of the related servers. Below that, we see our related CIs. Some quick highlights. We have 2 servers hosting .NET web applications, 2 servers hosting online banking databases, and 5 servers with the online banking software package installed. If random server 10 were determined to be part of our online banking application, a UCMDB administrator would have to drag and drop it into our model definition before it could be viewed in our query results. Back in our pattern view, we click Preview to see the results. Here we can see random server 10, and we have an additional online banking database. Let's take a look at our pattern-based online banking application. The first thing to notice is that our TQL looks eerily familiar to our pattern view for our instance-based model. However, we're missing a business application CI. The reason for that is we're actually going about the process of defining our business application CI. More specifically, we're defining our online banking pattern-based application CI. Now, this is important to note because any node that matches the criteria for this TQL will be automatically added to our application model. The criteria are any server that's hosting a SQL Server database, or has a software package installed, or is hosting a .NET web app whose name contains the phrase online banking. Let's take a look at the results for the query. Here, just as before, we see our online banking application and the servers that make up that application, along with their related CIs. One important thing to note here is random server 10 is already included because it's hosting an online banking database. The important distinction here is that any server that matches the TQL in our pattern-based online banking application will automatically be added to the application definition and then can be viewed in our query results. I discussed a scenario previously in which an additional database server was spun up to help with demand. Let's look at how our pattern-based online banking application would handle this scenario. Under normal circumstances, this new database server would be discovered by the HP UCMDB DFM process. However, for today, let's mimic discovery using IT Universe Manager. Here we have our random server 11 running SQL Server, but you'll see that we don't have an online banking database hosted by this server. So let's just create one. Now, back in our pattern view, we can query the results. Just as before, we see our online banking application CI, all of its related servers, and here we can see random server 11 who just showed up because all of a sudden we're hosting an online banking database. The important distinction here is that no UCMDB administrator had to be involved to add it to the online banking application model. Why do discovery? Why define a model? In other words, why go to all of this trouble? Applications defined in UCMDB can be utilized elsewhere or integrated with other tools. For example, the business applications defined in UCMDB can be viewed in Service Manager CI Viewer. Impact analysis can be run in UCMDB to determine what may be impacted if a given server goes down. Consider a server defined as being part of multiple business applications. Running UCMDB impact analysis will indicate which applications could potentially be impacted. Here we are back in IT Universe Manager, which is where we do our impact analysis. I've gone ahead and created a pattern view which depicts which database servers belong to which business applications. Here you can see both of our online banking applications. Here's our pattern-based, here's our instance-based, and the 4 servers that are associated with them. Little did we know that some of our 4 servers host other databases besides the online banking applications. Here you can see our online banking databases. And you can see that Random Server 11 and Random Server 10 are both hosting a payroll database, which ostensibly belong to the payroll business application. While Random Server 8 and Random Server 9 are hosting a human resources database, which likely belongs to the human resources application. To do our impact analysis, we select our servers that we're going to simulate being down. Let's go with Random Server 10 and Random Server 11. So what you do is highlight them, right-click, run impact analysis, and we'll set them as being critically impacted. Here this depicts Random Server 10 and Random Server 11 as being offline, and it appears as though both of the database servers for the payroll application are offline, so the payroll business application has been marked as critically impacted. Both of our online banking applications still have a few database servers left, so they're only marked as moderately impacted. Our human resources app still has all of its database servers up, so it's not showing any impact right now. Let's go ahead and run the impact analysis again, only taking one of these database servers offline. Let's go with Random Server 11. Mark it as critically impacted. Here, the payroll application still has one database server available, so it's marked as only moderately impacted. The pattern-based online banking application still has 3 database servers up, so it's only marked as moderately impacted. Here, the online banking instance-based application isn't showing any impact because we forgot to go in and manually associate Random Server 11 with this application model. This concludes my presentation of HP UCMDB. If you have any questions regarding any of the material that I have presented, please contact me using the information below. Thank you and have a good day.
Thank you for joining us for this first of 4 CMDB webinar series. Be sure to view the other 3 webinars from this series.